In the last video, where we talked about the James Webb Space Telescope's analysis of the planet K2-18b with possible detections of biosignature, the term 3Sigma or even 5Sigma came up. Today, we are picking up right where we left off and taking it one step further. What exactly is this sigma? And what do 3Sigma, 5Sigma, or even 6Sigma actually mean? At first glance, it might sound like complicated statistical jargon, but don't worry, sigma has more to do with our everyday lives than you might think. Whether it's about our work performance, test scores, or even how often we call in sick, sigma is almost everywhere. Let's say a year has 365 days and we hardworking employees grade through all of them, no vacations, no breaks. Of course, in real life, most people take a few days off, whether or sickness or vacation, and around 16 days per year is completely normal, which means you're a solid 2 Sigma employee with an attendance rate of about 95%. That's right in line with roughly 95% of the population. But now it gets interesting. Let's say you only missed one single day or were late once. That means 1 divided 365 is about 0.274%. And that puts you statistically in the top 0.227% of the workforce. And then that means you are just working for 99.73%. Congratulations, you are now a 3 Sigma office ninja. In the word of the Sigma, you have left most of your colleagues in the dust. You are no longer just a worker, you are Bruce Lee of punctuality. But now enter the truly ambitious ones, the caffeine-fueled machines, the relentless overachievers that say to themselves, I'm going to be a 5 Sigma productivity legend. Well, reality has other plans. To reach 5 Sigma, you are allowed to miss work just once every million days. That's about 4,806 years. So basically, you would have to show up every single day since the time of Wuzi, the Iceman, or since the Stone Age was being built, with 0 days off, no vacations, no sniffles, no remote work, no Wi-Fi, just you, your punch clock, and 48 centuries of pure display. Then and only then will Sigma tell you you are a 5 Sigma productivity miracle in human history. For most hardworking folks in the world, 3 Sigma is totally achievable, but 5 Sigma, that takes not just discipline, it takes a halo. Back from the realm of the immortal. So, what exactly is Sigma? Earlier, we joked that to earn the title of 5 Sigma work monk, you would have to go through 4,806 years without taking a single day off. But jokes aside, let's get serious. What's Sigma, really? If you have ever heard of statistics, then you have probably come across it. Sigma, the Greek letter, used to represent a standard deviation in a normal distribution. In plain English, sigma measures how much the values in the group vary from the mean value. Or in other words, how average are you within a group or how far you stand out. The further away from the mean you are, the rarer your result is. To apply sigma correctly in everyday situations, you need a large enough and detailed sample size so that a normal distribution or a bell curve can emerge. Let's look at a real-life example to make all of this more tangible. According to the Swiss Health Survey published by the Federal Statistical Office in 2017, a Dutch woman in Switzerland, the average height is 164.6. With a standard deviation of 6.5 centimeter, the sample size includes 10,380 individuals and represents an estimated population of around 3 million people or women. With a sample that large and a dense distribution of height values, the conditions for assuming a normal distribution are well met. And me, I'm only 158. Let's quickly calculate where I fall on the sigma scale. So 158 just minus the mean value 164.6, divide the sigma or the standard deviation 6.5 centimeters. And then it's minus 1, almost 1, minus 1. That means I'm roughly at minus 1 sigma, about 1 standard deviation below average. Not that unusual actually, since 68.3% of people fall within plus minus 1 sigma of the mean. So let's take a look at the height statistics for Swiss men. The adult man in Switzerland, the average height is 177 centimeter, with a standard deviation of 7.1 centimeter. The sample includes 9,117 individuals and represents an estimated population of about 3 million men. Now, let's look at this basketball man, a Chinese basketball man, Yao Ming. His height is 229 centimeter. So let's calculate how many sigma he has. So he has 229 minus the average height of Swiss man's 177, divided standard deviation of 7.1. We get 6.32. 6.32 sigma. What does that mean? The probability of encountering someone that tall is about 1 in 39 billion. In other words, a 7 sigma value is something that statistically should almost never exist. Now you probably feel very clearly just how far out Yao Ming is on the bell curve, right? We have been talking about sigma this whole time, but many people might still be wondering. You mentioned that the probability of biosignature on K218b is pretty high at 3 sigma. And just a moment ago, you talked about 7 sigma as 1 in 10 billion. So what is it really? A measure of probability or of certainty? The truth is sigma can be both. Let's go back to a simple example, human height. We mentioned earlier that Yao Ming is 2.29 meters tall. That makes him a 7 sigma person. In other words, a statistical unicorn, incredibly rare. Now, say you are trying to predict an adult height of a baby. With 99.73%, certainly you can say their future height will fall somewhere between 155.7 and 198.3 centimeter. That's the 3 sigma range. At the confidence level of 99.9999943%, the range is even wider, within 141.5 centimeter to 212.5 centimeter. You could call that the universal comfort zone for adult male height. If someone is outside that range, they are either a medical outlier or, well, it's Yao Ming or basketball man. Now back to K218b, the much hyped exoplanet. Scientists find chemicals in its atmosphere that might be related to life. They call it a 3 sigma signal. Sounds impressive, but what does it actually mean? Simply put, we are just 99.73% sure this isn't a coincidence. Or in other words, if this signal is just noise or a measurement error, there's some serious bad luck that only happens 3 times in 1,000. But in science, especially in particle physics, all the astronomical physics. That's still not good enough. There, it doesn't count as a confirmed discovery until you reach 5 sigma. At that level, the probability of error is just 0.000057%. Basically zero is as close to certainty as science allows. That's why many scientists say sigma is a true all-rounder. It tells you how rare something is and also how confident you can be in your result. Alongside the statistical 6 sigma, which we just discussed, you will often hear about 6 sigma in the world of quality control. But let's be clear, this 6 sigma is a whole different beast. Today, we are taking a closer look at what 6 sigma means in quality management, a concept born at Motorola in 1986, made famous by General Electric and Toyota, and now a standard tool set in the automobile business. When people hear 6 sigma, and many immediately think, all right, that's that statistical value with 99.999998% of accuracy, correct, but only half the story. In statistics, 6 sigma refers to an extremely low probability of error or outliers, essentially the mathematical ideal of error-free data. In quality control, however, 6 sigma is a structured, methodical approach to designing processes that are virtually error-free. It's a toolkit for companies that refuse to settle for good enough. Now here's the twist. Actually, you see in the right-hand side, in error tolerance, the 6 sigma is actually 4.5 sigma. And what's behind it? That's because in real life, process can drift over time due to machine wear, operator error, temperature change, error, etc. That's why a buffer of 1.5 sigma is deliberately factored in, a concept known as process drift. So in practice, we only control to plus minus 4.5 sigma, that's corresponding to about 3.4 error per million. Why the apparent contradiction then? Because 6 sigma is a statement, a symbol of mindset, ambition, and the relentless pursuit of excellence. Just like someone who sets out to climb Mount Everest, all 8,848 meters of it. They know the weather will turn, the path will be tough, and maybe they will be only make it to 8,000 meters. But no one says, I'm aiming for just 4,500 meters, not if the summit is the goal. Those who aim low will never reach high. In one sentence, 4.5 sigma is what reality allows. 6 sigma is what we commit to, not because we are already perfect, but because we choose to pursue perfection. This is the spirit that drives true industry. So what are the goals of 6 sigma in quality control? So the first goal is the error control with virtually zero tolerance, a maximum of 3.4 defects per million opportunities. That's like locking the word error in the vault. You won't see it again for a whole year. And the second is the processes as precise as a Swiss watch. Whether the temperature fluctuates, moral dips, or the material slightly changes, everything stays under control. The goal is consistent quality. No gold bars today and molten lumps tomorrow. The third goal is customer satisfaction. If the customer is happy and enjoys using the product, brand image improves significantly, while complaints and returns drop sharply. And the best part, the customer becomes a true fan, recommending you all on their own, like a tap water that just won't stop following. The fourth is the saving. Saving is everything for a company. Less rework, less waste, fewer returns, efficiency skyrockets. And the best part, you are not just saving money, but also saving nerves, and most importantly, your boss's temper. The last one is but not least. Everyone shall get involved, but with purpose. It's not about overwhelming people with meaningless KPIs. It's about using data and a method to improve processes together. Employees feel I'm part of that solution. Teams experience we achieve something together, and the leaders know the operation runs smoothly. Our final thought is that Six Sigma isn't dry statistics, it's grounded ambition. Anyone who takes every step in the process seriously ensures that defective products never see the light of day. Sigma is everywhere in life. Take our washing machine, for example. How often does it break down? If it has been running perfect for 10 years, it's probably already a plus 3Sigma durability hero. Or think about your school's standardization test. The average score is 70 with a standard deviation of 5. How did you do? Are you right in the middle, totally relaxed, or more on the edge of the curve, ready for liftoff? Sigma shows you, are you the high flyer or the easygoing middle of the packer? Clear, concrete, black and white. Sigma doesn't just judge, it just shows the distance. Sigma doesn't tell you whether you are good or bad. It simply objectively shows how far are you from the average. Maybe you are always early, consistently score high on tests, seasons your food just right, and are almost as tall as the ceiling. Then congratulations, you are definitely living on the Sigma curve and doing it in style. Thanks for sticking with me to the end. If you thought this video was okay, maybe even kind interesting, hit that subscribe button and drop your own Sigma story in the comments. What kind of standard deviation type are you? Thank you.